friends. Now we'll be discussing about the topic or the subject called as computer communication network. After this course, you'll be able to understand the basics of computer networks. Then what are the different topologies and protocols that are used for computer communication. Then you can understand the different layered network structures such as TCP/IP, then OSI model, etc. You'll be able to understand what are the different devices as well as what are the standards used for that purpose, and also what are the different protocols that are used at different network layers. So the contents of this lecture will be first to introduce you the networks, then why the network is needed, then the layered structure of the network, OSI model, network topology. So outcome of this course will be you'll be able to understand the network concepts, the importance of layered structure, and you'll be able to understand the different topologies. Now let us understand what do you mean by a network. A network is a set of devices that are connected for a communication by various links. So simply when you say that when different links are connecting together, we can say that it will form a network. So the best example is that the example of Facebook, your group, or WhatsApp, your group. You are linked with your group, and that forms a network of people. And similarly, when the computers get connected with each other for sharing the resources, we call it as a computer network. A network is simply a collection of computers or other hardware devices such as printers, routers, and any other devices that are connected together either physically or logically using special hardware or software to allow them to exchange the information and cooperate. Networking is the term that describes the process involved in designing, implementing, upgrading, managing, and otherwise working with the networks and network topologies. So the connection can be done through copper wires, fiber optics, microwave, infrared communication, or communication satellites. So generally these components are considered as a transmission media. Now there are three issues that we can discuss about network criteria. First one is the performance. The performance of the network, reliability of the network, and the security of the network. So the performance, it depends on the network elements, that is the computers, the devices that are connected to the network, and it is measured in terms of delay and throughput. So when we say that, then now take the example of mobile network, or generally we say that network is down. What does it mean? So network is down, it means we are talking in terms of performance, we are talking in terms of the delay or the throughput. That means we are not able to communicate, we are not able to transfer the data from one end to another end, or there is a delay in transmission. So that we call it as a performance. Then second thing is reliability. The failure rate of the network components, how frequently that device gets failed, that decides the reliability, and it is measured in terms of availability and robustness. So when we say that the network is not available, that means a certain device gets failed at a particular time. So that decides the reliability of the network. And the third one is the security. That is the most important thing in today's life. So we call it as a data security, data protection against the corruption or the loss or the theft of the data. So that may occur because of errors or malicious users. Now what are the advantages of networking? So advantages of networking. First one is the connectivity and communication. So it allows you to connect between the devices and allows you to communicate between the devices. It allows you the data sharing. That means data can be shared. So that now let us take one example that your computer lab has 20 PCs, and to get each PC, it is not possible to have a single printer for each PC. So what we can do, a single PC can be shared with all the PCs, and that PC and sorry that printer can be shared by all the 20 PCs. So this is called as a peripheral sharing or hardware sharing, as well as you can share a data which is available on your server. That server data you can share it and you can use it, so you can save the hardware cost as well as data cost. So internet access is the best example of this one, data sharing. So server, the best example is Google server, or any server that you love to browse. That server is at remote place and you are sharing that data, you are sharing the information across the globe on your PC. That is the beauty of this networking. Internet access sharing, we have already discussed. Then data security and management, so that allows you to secure your data as well as manage your data through various uh, networks. Then the performance enhancement and balancing can be achieved with the help of networking. And the last one is the entertainment. Then application, when we talk about the applications of the network, the first and the most important application is business application. For sharing of the resources through the client server model, the communication between employees at distant location, the communication between companies, suppliers and customers has been improved. The network facility is doing the best business with the consumers over the internet, or that is the best example, we call it as a e-commerce. The second application is home appliances, home applications. Peer-to-peer communication, which is different from client server model used for such application. The internet used for following applications is more popular: access to the remote information, person to person communication, interactive entertainment. The best example is Netflix. Then the mobile users. So mobile and wireless technology has become widespread and numerous applications are emerged with that one. M-commerce is one of the best example of that. So you can take the example of mobile banking. In other areas, the computer are extensively used. Computer networks are exclusively used are market and sales, banking services, manufacturing, then directory services, email, teleconferencing, voice over IP, and video on demand. So these are the few examples we can talk about the networking. Certainly, there are certain disadvantages of the networking. So the network hardware, software, and setup cost is initially high, so that we need to bear. Then second thing, hardware and software management and administrative cost is also high. Undesirable sharing, many times undesirable sharing occurs and intruders may introduce, hackers may get introduced if your security system is not good. So that at the cost of your data, we are at loss. Then illegal and undesirable behavior that we are talking about. Then the data security concern. So hackers have hacking your data, hacking your accounts is the best example of this one, and this is the disadvantage of networking. So your network is at the risk of security concern. Then on the basis of classification, there are there are three categories we can categorize the network. So first one is local area network, second one is wide area network, and third one is metropolitan area network. So simply we abbreviate it as LAN, WAN, and MAN. So LAN is generally for a short distance and designed to provide local connectivity. So the best example is the connectivity of the laboratories or the connectivity of your lab, or simply we can say that the connectivity of all the computers in your college or in your office, that we consider it as a LAN. WAN, it is for a longer distance. It provides you the connectivity over a large areas. So if we consider the distance wise also, so LAN is, we can consider it in 100 meters. So wide area network, we can consider it more than 100 meters to a few kilometers. So wide area network. So let us consider that your office is in one area, then your second office is in another area in the same city, and that gets connected, we may call it as a WAN. And again, the connectivity of such campuses and such connectivity within the city, we may call it as a metropolitan. And if your office is in different continents, we can call it as a WAN. So this is the example of this is how you can connect your LAN. So number of clients are connected with each other to have a uh, sharing of peripherals like printers, scanners, and etc. So this is the structure of LAN. So each PC gets connected with each other. This is the example of a wide area network. So you are in different countries and your offices get connected through satellites and various links of fiber optics, and they are get connected with each other. So this is the example of wide area network. This is the example of MAN, where you are at different campuses in a same city or in a different cities in a same uh, area. So this will be called as a MAN, where all the devices get connected through the various examples. As you can see that here it is a Ethernet switch which will get connected to the IP network, and then which is again get connected with site A, B, C, got connected with each other through the devices called as a switches, routers, and other devices. Now, what do you mean by protocol? So protocol. So whenever we communicate with each other, now let us consider that when I am communicating with you or when you communicate with your boss, we always prefer to wish him good morning, sir, good evening, sir. When we leave the place, we call him goodbye, sir, have a nice day, sir. So this is a part of protocol that we follow a certain rules and regulations so that we can have a good dialogue with each other. Similarly, computers can have such kind of protocols. A protocol is a synonym with a rule. It consists a set of rules that govern the data communication. It determines what is communicated, how it is communicated, and when it is communicated. It The key elements of the protocol are syntax, semantics, and timings. So these are the three areas, or these are the three key elements of the protocol. Now let us see what is syntax. Syntax is a structure or a format of data. That means in which format you are supposed to send the data. It, every structure has every syntax has its own structure. So that is decided by this syntax. It indicates how to read. It indicates how to read the bits or field delineations. Then semantics interprets the meaning of bits. the way we communicate with each other, the way we put the question marks, so we can understand the meaning of that one. So when we put the words that in our own language, that we can understand because we have that knowledge of semantics. So similarly, computer have their own knowledge of semantics. What is the meaning of bits that are followed, so that need to be interpreted, and it knows which fields define what kind of action. So that is decided by the semantics, and the timings when the data should be sent, and at what speed it should be sent, and the speed at which it should be received. So the best example is when we said that the speed is 1 megabits per second. So we said that 1 Mbps. So that means that our data is sent at 1 megabits per second. So mega means 10 raised to 6. So 1 mega, that means we can send 1 into 10 raised to 6 bits per second. That is what the speed of our data transmission. Now, the most important, the structure, the layer architecture. The computer network is based on layered architecture. The network architecture is a set of nodes and protocols that we have already seen. It describes the organization and the behavior of a network. The monolithic network is difficult to design and maintain as it is not flexible. Now let us consider that. Suppose if we want to build a 4-storied building. Now when we want to build a 4-storied building, we cannot go directly building uh, a floor at a time. We cannot build a building with a directly 4-storied building simultaneously. And even if we may build it, it will difficult to have a communication between the each floor. So it will be difficult to climb for from ground floor to fourth floor, and it will be difficult to come from the fourth floor to ground floor. So that communication between these floors, that will be very difficult. So such kind of building we can call it as a monolithic. That means in a single layer it is formed, and it will be difficult to design and maintain as well. So architecture models in modules and structured hierarchy results in layered architecture. So OSI model, uh, the network models, we can design it into two models. First one is OSI model, second one is internet models. Internet models is also called as a TCP/IP model. The OSI model is a 7-layer model, and TCP/IP model is a 5-layer model. What are the advantages of layered architecture? The layered architecture, it will reduce the complexity in design, development and maintenance. As I said earlier, it reduces the complexity in design. That means instead of uh, building a 4-storied building, now let us say it's a 7-storied building, as it is synonymous with our uh, computer network. So to build a monolithic 7-storied building and have a communication with each floor, so it is difficult to design. But instead of that, if we build a first slab, second slab, third slab, fourth slab with a internal connectivity between the two slabs with the help of staircase or with the help of lift, that will reduce the complexity, that will reduce the maintainability of your each floor, that will help you to develop each floor according to your own wish. This is what the meaning of this reduction in complexity in design and development and maintenance. Then the possibility of independent development of each layer, that is there. That means if you go for if your building is of 7 layer and there is no such discrimination between layer 1 or floor 1, floor 2, floor 3, then it will be difficult how you are going to develop each floor. But instead of that, if your each floor is separated from each other, you can easily develop your own floor according to your own wish. Similarly, you can independently develop your each layer in network also. So flexibility in implementation. Obviously, each layer is having its own importance, so you can easily implement it and you can have a flexibility in implementation of that one. Then possibility of making the changes on layer without affecting or working of other layers. Now this is again another a big example. If your floor section is not there, then you cannot change the sixth floor or the sixth floor information or a sixth floor contents. Even if you want to change the fifth sixth floor content, you need to change layer 1, 2, 3, 4, 5, because there is no support in between or they are not separated from each other. So layer 1, layer 2 depends on layer 1, layer 3 depends on layer 2, layer 4 depends on layer 3, and similarly the upper layers depends on lower layers. So that dependability is there when structure is monolithic. But instead of that, if it is a layered structure, then in such case there will not be interdependability. So you can make a changes in each layer without affecting the upper layer and lower layer. So there is a possibility of supporting variety of applications based on reduced number of common interfaces. So again, this is one of the example that we have already discussed. Design and analysis of system with different layer of abstraction is possible. Then the development and adoption of standards is easier, facilitating the production of devices and equipments by different manufacturers. So I can say that when we use a different devices, so these devices are compatible with other devices which can be used on a same platform. That means if the structure is monolithic, then in such case exclusively you need to design the devices which will support your own network. But if it is a layered structure, then in such case a different devices which are having different standards which are adopted by this layered structure can be used for application purpose even though the manufacturers are different. So certainly there are disadvantages of layered, or there are, we can call it as the limitations of the layered architecture. The information hiding may cause functional mismatch, which will leads to the performance degradation. So this is one of the limitation of this uh, structure. Then there are basic elements of the layered architecture. What it does, first one is it provides you the services, a set of action that one layer offers to the upper layer or down layers. Then the protocol, a set of rules that layers uses to exchange the information between each other, and the interfaces through which one layer sends a message to other layers. So these are the three basic elements of the layered architecture. Now this is the best example where we can understand the concept of network. Here is a sender who wants to send a letter to the receiver. So sender, what it does initially, so let us discuss on that one. So sender initially sends a letter which is written by a sender on a paper, and then which is put on an envelope, which is put in an envelope and dropped in a mailbox, right? Then after that This letter is carried from mailbox to local post office, and from that local post office to main post office, and that local post office, the letter will be delivered or carried out by the post office. So this parcel will now move from one source to destination. Now from one city to other city it will reach. So it will reach to the city post office of that second city where that information is sent. Now from that local city post office to it will go to the mailbox, that we call it as the letter box you are having at your home. It will be get dropped over there by the post office, and after that to whoever you have sent that the letter, he is going to pick up that letter. He will remove the envelope and he will read the message. So this is the best example. Now again we can discuss it about uh, the seven-storied building, a person standing on a seven-storied building, and the next person is standing on the seven-storied building of the uh, next to him, and there is a road in between. And let us say that if there is no communication, direct communication in between them, so how a communication will take place, or one person wants to send a data, so what will happen? The person has to come to the sixth floor to fifth floor to the ground floor, and from ground floor he will reach to the ground floor of the next seven-story building, and then he will climb up to reach to the next person, so that this is the personal communication happens. But when it comes to data, the data will follow the manner we have discussed in the post or the later case. So OSI model is defined by ISO. So ISO is the organization and OSI is the model. So keep in mind. So there is always confusion ISO and OSI, though the words gets exchanged. So ISO is organization and OSI is the model. So layered communication. So let us discuss about what do you mean by OSI. So OSI is the Open System Interconnection Reference Model developed by International Standard Organization. It is developed in 1984, and it is a reference model which is a conceptual model composed of 7 layers. So each layer specifies a particular network function. It is the basic and primary architectural model for intercomputer connection. An open system is a set of protocol that allows any two different systems to communicate regardless of their underlying architecture. OSI model is a model for designing a network that is flexible, robust, and interoperable. OSI model allows design of network system that allows communication between all types of computer systems. So that's why it is called as a reference model. So it will provide you the service architecture, it will provide you the protocol architecture. So these are the 7 layers. So first one is, we'll start from the lower layer. Actually, when we start with the actual application, we start with a higher layer, but now we'll discuss with the lower layer. So first layer is the lowest layer, that is called as a physical layer. The second most is data link. The third layer is network layer. Fourth layer is transport layer. Fifth layer is session layer. Sixth layer is presentation layer. Seventh layer is application layer. So bottom layer is physical layer and the top layer is application layer. So simply we can say that. Um, Now, many times, how to remember it? So, since this will be a case where we can discuss it, we can say that in Marathi it is called as APची bus, APची ST न्यू दिल्लीला पोचली. APची ST न्यू दिल्लीला पोचली. So A means application, P means presentation, S means session, T means transport, N means network, D means data link, and P means physical. So ATGSP ST New Delhi la पोचली. So this is the easiest way we can remember these 7 layers. So this is how actually the communication takes place and interaction between the layers to layers of two different OSI models, two different devices. So device A will communicate with device B. So the example here shown is device A is communicating. So there is an intermediate node is there. So two pink nodes that indicates that these are the intermediate nodes. So these are the intermediate nodes. So these intermediate nodes may be switches, it may be routers. So depending on where the device A and B are placed. So this device A is communicating through these intermediate nodes with device B. But actually how it happens, let us see. So device A wants to send a message to device B. So application layer had device A, which will have an interface between application layer and presentation layer. So this interface will have an interaction with each other. So the information from application layer will be sent to presentation layer, and from presentation layer to session layer through the interface between these two layers. Then the session layer to transport layer to network layer to data link layer to physical layer. Now these physical layer will have an interaction with these intermediate nodes. These intermediate nodes will have only 3 layers, which consist physical layer, data link layer, and network layer. So these 3 layers will have an interaction with each other, and intermediate node will again communicate with the intermediate node with each other, and the second intermediate node will discuss with the physical layer of the device B. Then the data link layer will communicate with network layer. The network layer will communicate with transport layer. The transport layer will communicate with session layer will communicate with presentation layer, and the presentation layer will communicate with application layer. And this is how the communication takes place. But when we talk about this is how the information has flowed, but when we say that the application layer of one should be matched with the application of layer of second device, then and then only the person B will be able to understand what the message means. So we call it as a peer-to-peer protocol, which is agreed by both the devices. So device A will agree that okay, this is what the protocol of application layer, that you must agree with the protocol layer of application layer of protocol device B. When both are matched, then and then only the communication will take place. So this we call it as a peer-to-peer communication. So you can see that the dotted lines between the two layers at layer 7 peer-to-peer protocol will take place. At layer 2 peer-to-peer protocol will take place. At layer 3, layer 5, layer 4, and similarly each layer is talking with each layer of devices, and this is how the communication takes place. And when it comes to the physical communication, your actual data is sent in the form of say optical or electrical signals. Now this is the best example of communicating the data. So when the data comes to layer 7, so that is indicated by D7. So D7 wants to develop its own protocol, so that has to be understood by D7 layer of device B. So it will add a header called as a H7, so that the information gets split. So this H7 and D7 will become a data for layer 6, and again layer 6 will add its own header information, and the process goes on. And at final level, you can see that at physical layer, at data link layer, which is related with some information related with the error correction and detection techniques. That's why header and tailor information gets added over here. And at final stage, you can see that the data gets converted into binary data, and this binary data gets transmitted through the transmission media. So as I said earlier, the transmission media will be used with sorry will be uh, maybe your wired transmission or wireless transmission or fiber optics transmission. And similarly, at receiving end, you can see that the received data is again, that data gets transmitted to the next layer, that is the data link layer. The data link layer will extract the information of header and tailor, and these header and tailor will get removed, and only D2 will be transmitted to the next layer. The network layer will remove the header, and D3 will be transmitted to the next layer, and similarly the information will be transmitted to the upper layers. And at 7th layer, H7 and D7, so H7 information is known to the protocol, so that H7 information is removed and D7 is given to the device B. So device B will be able to understand what the data will be. So this is how actually the exchange took place using OSI model. So in next lecture, we'll discuss about the different models or different layers in details one by one. So thank you very much.